In this particular example, we're given the function h of x, which is equal to 3x squared minus 5x all raised to the 7th. This function is a composition of two functions. There is a quadratic function embedded within a 7th degree polynomial. In order to take the derivative, what we have to do is use the chain rule. And there's two techniques for doing this, both resulting in the same answer. We'll start with the slightly more difficult approach that is used to introduce this particular topic. What we have is we've written the function as y equals 3x squared minus 5x all raised to the 7th. What we're going to do is let u represent the quadratic portion of that expression. The u will represent the 3x squared minus 5x. What that does is it creates two functions here. One function is y equals u to the 7th, and the other function is u equals 3x squared minus 5x. If I take the derivative of the first function, y equals u to the 7th, that derivative would be called dy du and would result in the expression 7u to the 6th. When I take the derivative of the other function, u equals 3x squared minus 5x, its derivative would be called du dx, and it would produce the expression 6x minus 5. From what you've read in the textbook, you have learned that dy dx can be expressed as the product of dy du and du dx. Therefore, substitute in dy du and du dx from the previous two steps, and you end up with 7u to the 6th times 6x minus 5. Well, we know that u is equal to 3x squared minus 5x. Therefore, we can say that the derivative of this function is 7 times 3x squared minus 5x, that all raised to the 6th, times 6x minus 5. Now, this question could be handled in a slightly easier fashion. When you take this function, 3x squared minus 5x raised to the 7th, you can look at it as a function embedded within another function. And you start by taking the derivative of the outermost portion using the power rule. So for example, using the power rule, you would take the 7 and multiply it by the existing coefficient, which is 1, and you end up with a new coefficient of 7. And then you reduce the exponent by 1, so the exponent which once was a 7 now becomes a 6. Then you must multiply that by the derivative of the inner portion, or the inner function, in this case the quadratic function. And that's what I've indicated. That's why we have a d dx of 3x squared minus 5x. In the final step, I write my 7 times 3x squared minus 5x raised to the 6th from the previous step, and then I multiply that by the derivative of 3x squared minus 5x, which is 6x minus 5. If you return to the first method that we used, you will notice that this technique produced the same derivative.